morning and welcome to another great chamber program. This month's September 2020 Friday focus is on McGuire Nuclear Station, and we appreciate you joining us and tuning into this valuable content. As chamber members, we are constantly looking to add value and help out in any way we can, and in this type of communication, this will be an excellent program for you to listen to. We do thank Duke Energy for being our speaker, as well as being a great corporate partner with us and serving our members. I'll turn it over now to our 2020 Public Policy Chair, Jeff Tarte, who will facilitate this program. Jeff?
Thanks, Richard. Before we get started this morning, what I'd like to do is introduce Jennifer Husky. She is with Novant Health System, one of our great members, also Novant, which is one of the truly spectacular healthcare providers in our entire region and around the Southeast. Jennifer, if you would, thank you for being a sponsor. And if you've got maybe a short update on kind of COVID and things going on in the area, that would be most appreciated.
Absolutely, Jeff. Thanks so much. We are, of course, always pleased to sponsor and participate in all of the chamber events. But specifically, I want to make sure that we kind of get out there. We have an update coming to you all, to all of our chamber members and anybody from the community that wants to hear an update straight from Novant Health. Dr. David Priest will be presenting on September 29th from 3 to 4 p.m. He'll give a basic COVID dashboard update, as well as then a prime time to ask any questions you may have about trends, about vaccines, any information. He gives us at Novant Health an update bi-weekly so that we as team members are kept as updated as possible as we're out in the community mixing and mingling with folks. So this is an amazing opportunity. This is the first one he's done in the North Market. So September 29th from 3 to 4 p.m. Thanks, Jeff.
You bet. Thank you, Jennifer. I appreciate it. Well, with us today, we have a real treat. In our backyard, as most of you know that have lived here for any amount of time, is McGuire Nuclear Station. Ironically, I can see the top of it from out my back door window. So I live very in close proximity to this a marvelous resource that we have in our state. Tom Ray is Vice President with Duke Energy, is with us today. Tom's got over 30 years, I guess, with Duke. And interesting enough, that almost becomes a career, I think. Tom, by profession and training, is a nuclear engineer, got his nuclear engineering degree, I believe, at NC State University. Amazingly smart man that can pass that kind of curriculum. I know you have certifications around running that are required to actually run and operate the nuclear station. I know your title is officially Vice President, but when you run a facility like McGuire in this region, your title is officially the man, and he is responsible for all aspects of McGuire. And we'll get into some of that today. And Tom's got some updates for us on what's going on at the station, some things that are activities that will be in the short horizon that we all need to be aware of in our region. So Tom, I'll give you the floor, and thank you for being with us.
Thank you, Jeff, and thank you for that introduction. And yet, what I would like to do this morning is give you a feel of McGuire. I'm not going to go into the technology, but if you have questions on the technology, I'll definitely answer that. Talk about how our role in the community, how we interface with the community, give you an update on upcoming events at McGuire, and give you an update on how we are managing the pandemic. And so I really appreciated the comments there at the beginning by Jennifer, because it's something that is on our mind constantly, and it's something that we have been working through ever since back in March. And so Duke Energy and McGuire has been part of the community here for a long time, longer than I've been with the company. And it's something we take a lot of pride in. I've been here a number of times. We're supporters of our local schools, supporting, many people who have been up close to McGuire did it while they come out to see our summer concerts that we do with the Charlotte Symphony. We didn't get to have one this year because of the pandemic, but we had one every year for the last 20 years. And our goal is to, once the pandemic does clear, to be able to go back to providing that opportunity for the folks around the Lake Norman area to come to McGuire, get comfortable with this facility being here. It's, you know, it's been here, construction started almost 50 years ago, and to understand what the plant does here in this community. Let me tell you a couple more things about myself and my family. You know, Jeff went over my background. I did grow up in North Carolina. I went to North Carolina State University, graduated in '87, nuclear engineering. I actually have a couple of my classmates that I graduated the same year with in that same class here at the site as well. 31 years with Duke Energy. Spent a couple of years in construction, in nuclear construction around the country before I came back home to, at the time it was Duke Power, and started back with Duke, started in 31 years ago. I've been at 4 of the Duke locations. I started out in their corporate office. Then I came to McGuire, was at McGuire for about 10 years. Early in my career, like you said, that's where you get all the operations certifications, the additional training on these facilities. You know, early in your career, that's where we tend to get all that. Later, you get the business and the leadership training. Left McGuire and went down to our Catawba facility. Most people may not realize is that we have a nuclear plant on both the north side of Charlotte and the south side of Charlotte. We have one down on Lake Wylie as well, and it's almost identical to the one that's here on Lake Norman. Spent about 7 years there, and then I was asked to go down and lead as the plant manager the Oconee Nuclear Station, which is down near Clemson, South Carolina. Was there for about 7 years, and then 3 years ago was asked to return to the Lake Norman area to lead the McGuire station. So I was very happy to come back to McGuire. Some of the folks that were here when I was here earlier are still here, so it was like coming home, being from North Carolina and having my family grow up in this area. It was definitely like coming home. My wife and I live in Huntersville. I live about 4 miles from the plant, very close to the plant. Makes it very convenient to come out to the plant, to drop in, talk to our operators on the weekends and the like. We have 2 daughters. My oldest daughter, Emily, is a 4th grade teacher, and my youngest daughter, Madison, is a senior at the University of South Carolina in music education. And so we look forward to her graduating soon as well. So we also live very close to the plant. We live here in the Lake Norman area in Huntersville. You can go ahead and switch to the next slide. There you go. Thank you. Just this is a general slide. Most people may not fully know the background behind nuclear power. You know, nuclear power is unique in that it is definitely, it's carbon free. Nuclear plants operate 24/7 around the clock. We're about 20% of the nation's power. About 50% of the Carolinas power comes from it. There's 96 reactors in the United States. At one time, we were up to 104. We've had they do at some point go through their useful life and are shut down, decommissioned, and dismantled. 29 states have nuclear reactors. The Carolinas is one of the areas that has a concentration of nuclear, which is an advantage that we do have in the Carolinas. There's 57 plants in the country operating those 96 reactors, and all that is carbon-free emissions. If you look at nuclear across our country and across our state, we're producing 55% of the carbon-free electricity. So it's absolutely part of move our environmental friendly, carbon free power generation. We provide, the nuclear energy provides power to over 4 million customers in the Carolinas for Duke Energy. And you know, when some of those customers are through co-ops, and we do provide power to our co-ops, our rural type of facilities as well, where we may not provide it directly, we still are a supplier right to them. You can go on to the next page, and we'll get into talk about McGuire. So it has been amazing to me as there's been more transition of folks around this area, around Charlotte, just how many people I run into that don't realize that there's a nuclear plant on, switch to my data there, to a nuclear plant on Lake Norman. It amazes me, and so, which is good. It means we're doing our job well. We're not doing those things that put us in the news, make us get noticed. But we began construction here at McGuire in 1971, so almost 50 years ago. And that was about 8 years after the lake was formed. The lake was formed about 1963. Lake Norman was formed. It was a primary cooling source for a number of electric generating facilities, as well as being a reservoir for Cowens Ford Dam, which is also a generating facility and a source of drinking water for the areas in Western Carolina region. The lake is one of 11 lakes that's on the Catawba River chain that we also operate. The lake between Lake Norman and Lake James, they make up 50% of the water storage on that lakes, those 11 lake system for drinking water for those regions. 67% of all the usable water out of those lakes is coming from Lake Norman and Lake James. The plant itself began construction back in the 70s. You can see there's 71. We put the first unit in commercial operation in 1981. So we are quickly coming up on our 40-year anniversary, which is a key milestone for a nuclear plant. All nuclear plants are initially licensed for 40 years. And you'll see on there where it says licensed to operate until 2041, that's more than 40 years. If you look at 60. So about the 20-year mark, we started looking at the plant and we got a relicense to be able to go an additional 20 years. So next year we will actually cross into the area we call the extended power operation region, which is the second license that we'll have. And in a minute, I'll talk about our reviews that we're doing to go even further to up to 80 years. And so we'll be here, if you look at it, if we go to 80 years, McGuire is just now about halfway through its life cycle. 39 years it's been here on Lake Norman, actually generating power. We have 2 units. If you look at that picture, you'll see the 2 units. That's the picture most people see that come out to the symphony, because that is from taking a picture from our energy explorium that's over on our facility as well. The property actually has more than just the power plant on it. In addition to McGuire, we have what we call the McGuire Island. That's what we refer to it as, but it has our Applied Science and Environmental Center as well. And it basically does the monitoring of the lake, of Lake Norman, also provides facilities for our environmentalists at our other lakes to also take that data and monitor and knows if we're having any impacts or providing any data to the states and the counties as far as what's going on with the lake system. Science Center, where different facilities across Duke Energy send things to be, materials to be evaluated. If we have a material that looks like it's failing or it's not operating properly, we can send it there to be inspected and checked out and give us a report. The facility is about 700 acres. We have 2 units, 2 reactors on the site. These are larger reactors than most locations. You can see they're 1,200 megawatts. A kilowatt hour is what it gives you about 1 home's worth of power. And so you can see there we're providing power to almost 2 million homes is what McGuire can provide. This is a gem of the nuclear industry. We are currently in the top column of all of the regulator. We have the NRC, which is the Nuclear Regulatory Commission. They do reviews on the plants and provide a rating or a score in different areas. And we are in the top area for all areas that they evaluate. We also have an internal industry company that also evaluates and provides feedback and ratings to the facilities. We have been a top rated facility for over 25 years, one of the best and longest running plants in the industry for having that rating. We are also one of the lowest cost generators in our industry as well. We typically compete for one of the spots in the top 5 in the country. Part of that is that we are very reliable. We operate well over 90% of the time. We should take the plants out of service for maintenance outages occasionally, but well over 90% of the time, being large units, that makes us some of the most economical units in the industry. As far as you can go to the next page, Jeff. As far as our nuclear, we call it a fleet. I mean, kind of a naval term because of a lot of the folks that at one time, a lot of the folks came from the Navy into our industry. Not so much now, but we still do get some folks in the Navy. So we do use naval terms like fleet. And so our fleet, nuclear fleet for Duke Energy, comprises of 6 locations with 11 reactors. You can see there's the list of the reactors. If you look in the center of that map, you'll see the Mecklenburg County. You can see the dot at the above and just south of Mecklenburg County in northern South Carolina on Lake Wylie. Those at the McGuire and the Catawba facilities, very close, similar to each other. And you can see the other 4 facilities spread out across our operating region. Gives us a lot of capability because we now have experts in nuclear power at 6 locations that we can draw into any one location. So we do operate as a fleet. You'll see a little asterisk there next to the Catawba facility. That's because, well, we are partial owners of the Catawba facilities. A number of the regional co-ops, municipal power or entities also own Catawba along with us as well. And so, but we operate the Catawba facility as well as being a co-owner of that facility. You can see there that the Robinson plants, the years that the plants will go through their current license extension. License is listed on there, so you can see some of those will start expiring. Especially our Robinson plant will be one of the first ones in 2030, and then we are looking at extending that. And I'll touch on that in a minute as well. You can go to our next slide, Jeff. So I just want to touch on, this is where I want to talk about some of the economics of nuclear power. And I think that for a group like a chamber would be very interested in. So, you know, a typical reactor will employ about 700 people. We have 2 here, so we actually have about 1,000 people that are employed at the site. About 800 of them work directly for Duke Energy. And about 200 of them are contingent workers that come in and do specialty jobs for us as well, but they are here with us all the time. We have an operating budget at McGuire of about $85 million a year to operate and maintain the facility. And then there's other costs associated with fees, costs we get from corporate, stuff like that for the services they provide. But the amount that we have here available each year to operate in is about $85 million. And about $60 million of that is payroll. And then as far as capital improvements, we spend about $60 million a year doing capital improvements on the facility. Very reliable facility. You can see there 90% of the time that the plant is operating. Definitely have local benefits with that many workers on site. And also the schools benefit locally from us. We also provide a lot of, these jobs are high-tech jobs, a lot of engineers, scientists, and so we really encourage our employees here at the site to get out and be involved in the community. They really help the local school systems. They also do things like science fairs, community drives, those types of things. So we're always very proud of the impact that we can have on the facility, on the local community here at the plant. Many of you probably have been to the Energy Exporium and got to see the technology associated with the McGuire. I will tell you that what I like about the nuclear is that the base load, always on 24/7 power, really integrates well with things like solar. You know, the solar, because of the nature of you don't have control of the fuel, can go up and down. We can provide that base load, don't rely on external factors like the sun, the wind, rainfall for hydro. Even our natural gas and our coal facilities do require a constant feed of fuel. We bring our fuel in all at one time, and then we have it here on site, and we can operate for 18 months straight without having to refuel or have to worry about where that fuel is coming from. It's already here on site, and we have control over our fuel supply at that point. So it really balances well, being carbon-free, having the fuel on site 24/7 with renewables as well. So let me talk about, you can go on to the next slide, Jeff. Let me talk about subsequent license renewal. You may hear that comment. So going forward, the company is really moving towards a carbon-free generation. By 2030, we should be at least 70% reduction in our carbon emissions across our company. That's actually an improvement from originally when we had these discussions. It was at 50%. It's moved to 70%. So that in order to do that, Duke Energy definitely has to continue to operate the nuclear plants to be able to meet those goals for carbon-free generation. So all 11 of our facilities right now are slated for what we call subsequent license renewal. So I showed on the previous slide where these plants are licensed for an additional 20 years, so then 60. We will be looking at moving these now to go out to 80 years. So whereas McGuire's licenses were to expire in the 2041 and 2043 range, we will now be looking to move them to be able to operate until 2061 and 2063. And that'll give us that bridge. There is new technology coming along with battery storage. There's new technology with small modular reactors, and we are definitely involved with both of those. Both those support the carbon-free generation. And that move of allowing these plants to get to that point will allow the technology to progress to be able to make that transition from a carbon-based generation to a carbon-free generation. And nuclear is definitely part of that equation to be able to do that. And so the folks who have been here since the plant started, we started construction in 71, went in out service at 81. Most will be our grandchildren will actually be around when these plants actually see the end of their life. We have a lot of questions about how do you get to that long if it was designed for 40 years. We have found that we can replace almost any component, and we do. I mentioned the capital improvements that we do on the facilities. Some of those are improvements to go from an analog technology to a digital technology. And some of those improvements are just replacing large components in order to allow us to continue to operate the facility. There really are no components at McGuire that we couldn't replace to keep it going all the way out to 80 years. And we have specific inspection programs we do. Our regulator has come in, we gave them a plan for how do we extend the plant out, what do we inspect, what kind of testing we do, what type of materials reviews we do. And they looked at that. We put those plans in place, and as we go across the first extension, they come in, inspected us and said, okay, you are ready for that first transition, which is next year. And then they'll do the same. We'll present a plan to them. How do we extend the life of the plant out to 2060s? And then they'll review those programs, and they'll come in and inspect us to verify that we're making those changes in order to extend the life of the plant. Next slide. I think we're getting close to the end. Okay, I wanted to talk about COVID because I two specific topics today. I wanted to talk about COVID-19 response, and I also wanted to talk about what we have coming up for a refueling maintenance outage that we're about to embark upon on Unit 1. So first, as far as COVID, so we were in a maintenance outage, about to enter a maintenance outage in March. March 19th, we entered a Unit 2, our Unit 2 went into a maintenance outage. And that outage is where we basically take one of the units, shut it down, and go in and do maintenance that can only be done with the plant out of service. We're always doing maintenance to the plant, but there's certain maintenance and refueling that we can only do with the plant out of service. Now, when we're out of service, we have other facilities, including the other units, that continue providing service to the grid. So customers don't notice, other than they may see increased traffic, they may see increase of people in our hotels, in our restaurants, because we bring in quite a few people, and I'll go over that in a minute. So in March, we saw it coming, we're ready. We actually have a procedure for a business continuity procedure that looks at all kinds of things. We've always had one. It really got beefed up after 9/11, back at the early 2000s, got beefed up. A part of that was we went through the H1N1 pandemic. Some people may not remember that one from the 2009. So we actually had made some adjustments to that back then. It didn't have a big impact on us at that time, but it basically wrote procedures for how we would handle a pandemic. And so it came here, we pulled our procedures actually in February, saw it coming, said, hey, if this gets worse, we may have to implement. And so we've put a number of things in place at that time, and we've continued it through the summer, and we're including it in what we're about to do with doing the maintenance outage on Unit 1. So at arrival, and this was controversial at first, we actually put a checkpoint at an entrance to our plant. Our security team mans it. There's a screening you go through called a wellness screening. Come in, they ask a series of questions to verify that you don't have any symptoms that could be showing that you're bringing the virus on site. And then we do a temperature check as they come in. We do that for all employees. I went through that even this morning. I went through that. We've given all of our employees PPE, so they masks. Every employee is required to keep a mask on them at all times. If they're in a location where they're around others, they're expected to don the mask. There are places where they're out and they're alone and it's hot, and so we do allow them to take it off, put it back on when they get around others. But you'll normally see folks around our facility, if you're here, in masks. We do travel screening, so anybody who travels, I will be notified, our plant manager will be notified, and we have certain criteria that we go through and say, if you do certain travel, you will go into a quarantine state. Earlier in the year, like when we had our maintenance outage in the spring, that was a bigger deal because we have people going to New York or the areas where there are hot spots. We'd have to check on that. The interesting thing is now that we're bringing people here, we're now actually considered the hot spot for others that are coming here. And so they're usually asking us lots of questions about what is going on in the Charlotte area related to COVID, and we're able to answer their questions around that. We do on site, the temperature monitor mentioned, we do physical distancing, social distancing. If you come around our facilities, you'll see circles on the floors that kind of every 6 feet throughout our halls, in our conference rooms, anywhere where people could gather to make sure that people see it. We have routine cleans. We've actually increased our janitorial staff to do routine cleanings. We've given hand sanitizer stations and hand sanitizer everyone's, and we've moved some of our work teams to be further apart. We have case management. Anybody who thinks they've been exposed gets notified to us. We put in a tracker and we track them through the process. We quarantine them at home. We do keep them whole for salary, recognizing that could be a way for them to be discouraged from reporting it. Is if I'm out sick, am I going to get paid, not get paid? We always make sure that one of our processes or programs will make sure that they stay whole through that period while we keep them out and bring them back so that they don't feel like they have an incentive to not report. And we have seen very good reporting from our teams. So we also do a contact tracing on site. We've had some people report positive cases. We quickly get them out of if they're on site, quickly get them out of the site, and we do contact tracking here, have them note anybody who they've been close to, and we follow up with those, get those folks tested. We've been able to show that we've had no on-site positive transmission. All of the exposures that have occurred have been off-site. Most people will be able to point to specifically where the exposure occurred, and we've been able to follow them through that. So we've had it's been less than 2 dozen of those come through. We've had a large number of people report that they believe they were exposed and get them to a point to where they were able to get tested. And then offsite, we really encourage people to take the materials we provide home with them, use them at home. But we have found that offsite is where people are getting their exposure, and we have been successful at keeping it offsite here. As far as our licensed operators, the operators that actually operate the reactor, we treat them special. We keep them separated somewhat from the rest of the workforce, give them additional items to kind of keep them, make sure we don't do anything to our licensed operators. We've been able to keep it out of our facilities that actually operate the plant as well. And so we believe we got a really good strategy. We went through our last maintenance refueling outage last spring on the Unit 2 unit, and actually we're able to keep it out during that period. This one's gonna be a little more challenging, I think, because it's got more of a foothold in the local community. But we've been able to show over the last 6 months that we can keep it out of the facility somewhat successfully. If it gets in, we have a plan for how we go and clean as well. You can go to the next slide, because I'll talk about the last section. We'll get to questions. I want to talk about maintenance and refueling outages. I had kind of mentioned this a minute ago. And this is where as far as economic impacts to the businesses around the plant, that they probably see this. And folks who travel around the plant, normally we don't have much impact on the local roads. If you watch now, as far as about to go into this, is that we all of a sudden have an additional 1,000 people coming on site. So refueling and maintenance outage for us happens about every 18 months. We actually will swap out 1/3 of the fuel in our reactor, and get it ready for the next 18 months worth of operation. We do that for each unit, and so about every 9 months it usually occurs, and they're 18-month cycles, so they tend to get, sometimes we get 2 in 1 year, and this is one of those years we're getting 2 in the 1 year. And so that time is where we actually replenish our reactor cores and allow it to go 18 months without shutting down again, which is very critical, and we couldn't continue to operate the facility if we did not refuel it. So during this refueling outage, about 6-week window, 1,000 extra people will come in, especially skilled people that will help us do the maintenance, help us do the refueling. When they come in for the COVID part, every one of them that shows up has to provide evidence that they were tested negative in the last 7 days. If they can't provide that, we do have a facility where they get in process into our company, because they actually support multiple outages throughout the fall. They'll go from here down to a Coney and then to our Robinson facility a lot of times. When they come in, they have to bring that, or we test them. We will test them before they show up. They get per diem. They stay in local lodgings. They eat meals locally while they're here. But we have verified that when they show up, they are negative for COVID when they show up. So then we go into an outage. That outage lasts for about 3.5 weeks. Unit 1 actually shuts down tonight. We typically don't put that out in advance because that gives others who supply power to backup power to us if we don't provide ourselves. They know when but we are shutting down that unit tonight. For that unit, we'll go into that refueling outage. All the extra 1,000 people are here now. We've actually started bringing them in about 2 to 3 weeks ago. They went through our in-processing facility and they came in and helped us pre-stage and get ready. It's extremely choreographed type of activities. We go from beginning to end. Well over 120,000 tasks will be completed during that window. We're bringing these extra 1,000 people as well as the 1,000 we already have here on site. About $33 million will be spent during that window. About 27 million of that on operation maintenance costs, and then another $5 or $6 million on capital improvements that we'll do. So huge impact, very short-term impact to the local communities. For the folks that drive by the plant and the roads are a little bit more congested, we do set up our timing. It's more for get people on and off more efficiently. I set up a timing of shift change and stuff like that. But really, we try to get a little bit outside of the rush hour windows, and so our folks will usually be already on site by 5:30 in the morning, and they usually will get or usually around 4:30. They'll start getting out, or some of them will leave at the 7:30, 8:30 range in order to kind of miss those rush hour windows. We are a little unique being near Charlotte with the traffic. Most of our facilities don't have to worry about those types of things, but we are conscious of the impact that we have on the highway 73 and on our ability to get people on and off site. And so a lot of folks probably see that part. Now, we do have discussions with our team with the COVID going on about when in the evenings, when they're in the hotels, when they go out to the local restaurants, when they get food and go to the grocery stores, that type of thing, make sure that they're taking their PPE and supplies with them. We're watching very closely to make sure that we're not trying to bring anything that comes back on site with the COVID. They'll go through our screening every day and report out to us if they think that they have any symptoms. We did that in the spring. It worked very well. We got a side benefit. Sometimes we would see illnesses, get into the plant during a refueling outage, having 2,000 people working together. But all of our supervisors reported, hey, this worked out really well. Not only did we keep the virus out, but we kept just any sickness out during that window. And said something that probably should be doing this all the time, not just when we have a pandemic going on. So I think we'll have a successful refueling and maintenance outage that will start tonight. I think I'm up to questions, Jeff.
All right, Tom, it is a fascinating topic. I've got a number of questions that have come in and things that I have here that we'll kind of review. We're going to probably need to schedule an all-day seminar to address all the things that we have on the list. And we got about 10 or 15 minutes.
Okay, I'll try to be quick on the answers too then.
All right. First of all, if we can start maybe with the life expectancy, because that has long-term ramifications for the does. And I know that, you're looking at nuclear facilities that traditionally have an 80-year life cycle. We're halfway through already. takes 10 years to build one. And maybe you can talk both life expectancy and licensing through NRC and FERC, because that's not like, okay, you send it in and next week we get approval. What's the thought when we get to the end of the life expectancy, decommissioning, what's going to replace this volume of energy and power for our region? What's the thoughts from Duke?
So we just submitted, and you can go out and find this on the internet, we just submitted our integrated resource plan, and on there had various scenarios that we talked through. If you go look at that plan, you'll notice some features of that plan that you may not have seen the last time we issued one of those plans. There are some renewables on there. There's more solar. Half the new generation that we're putting on our system right now is renewable or solar. You'll see some wind. We don't have as nearly as much wind in this area. It's more in the Midwest and Texas, but we are looking at offshore wind. So that'll do some replacement. But one of the things that I'm excited about that you'll see on that plan as well is small modular reactors. There's a number of designs out there, 4th generation designs. I mean, if you look at it, we had the early designs, reactors from the 60s and 50s. And then we went through, this is considered a 2nd generation design that we operate here at McGuire. The 3rd generation designs are like the new plant that's being built down in Georgia that people know about near Augusta, is a 3rd generation plant. 4th generation is now being designed, and some of the new licensing for those 4th generation plants are just now getting approved. And some of them are very exciting. You may have heard of TerraPower. Bill Gates is being one of the founding members of TerraPower. Duke Energy is part of the group that's working on new designs. Small modular reactors, basically more in the 340 megawatt. This is 1,200. So about 1/4 the size of these plants, but you can build multiple ones of them. They operate at atmospheric pressure, and so that makes them safer. You don't have a motive force if you have a pipe break or something like that to push out of it. So they're safer because they actually operate at environmental conditions. I think that will be one of the things that come in and take its place. The other one is battery technology. Duke is out there with a lot of the research facilities putting batteries, grid level, commercial level batteries onto systems. Between small modular reactors, battery, and continued improvement and life cycle of solar and wind, I think that those will eventually be the keys. I mean, we need a bridging strategy to get us from 2030 to where we think that the technology on batteries will be to where it can kind of help on a bigger scale about 2050 is where we think that the technology will take us to where we can really rely on batteries. And so you can see that transition away from the traditional coal plants, even the natural gas plants, which a lot of those were built in the last 20 years, transitioning away from that as well to a carbon-free generation footprint. So I think between small modular reactors, giving that base load power, battery technology, the improvements in life expectancy on solar and wind, which the life expectancy on solar and wind is not as long as like a large generating facility like this, 80 years. Typically you can get out of a wind plant 20 years, 25 years maybe before you have to basically, it costs more to maintain it than just to replace it. And so
obviously storage is an issue in the technology for solar and for battery, but with the new nuclear technology, people were curious, are they water-based, water-cooled? Will they have to stay near a lake or can they be placed anywhere?
Well, they'll still need a cooling source, an ultimate cooling source available to them. Some of the newer technologies are not water-based in the plant. The ones that are showing most of the promise right now are sodium-cooled reactors. Sodium has a unique property. It has a very low melting point, so liquefied sodium can be something you manage, but it has a very high freezing point. And so you have a large range to work in. So a lot of the technologies are looking at a sodium cooled. So the reactor itself will be sodium based, but it will still need a source of water for the ultimate cooling. And it also needs a source of water because once you get to the point where you get beyond how you create the heat, the rest of the plant works very similar to any other large generating facility with turbines and electric generators. And so it needs that steam power. So it'll still need a water source.
So on the licensing, we go through that process every so often. And what are the things you or Duke is concerned with that could prevent being approved to extend the license?
Well, if you look at where Duke is right now, we've already have a permitting license to build a plant down in South Carolina. Was going to be the Lee plant. When we looked ahead, the power generation, the efficiency all made it so we didn't have to build that plant. But we still have the license and the environmental studies, and also we have a location that we could use. We'll have some additional licensing work because it was licensed for a specific type of plant, but a lot of the reviews have already been completed. So there's a facility, a location that we could put one fairly easily now. As far as these facilities, some of our facilities, the footprint is large enough that we could put those additional reactors on the sites that we have now. McGuire's is a little tight. Our actual footprint here is about 700 acres. I haven't heard any discussion about putting one here, but we do have it in the Carolinas regions, have sites that could relicense their site to handle a small modular reactor. Most of the challenges is just getting, doing the environmental studies, getting the local residents comfortable with a new reactor technology in their community, are the types of things that we would have to work through still.
For McGuire's kind of hitting its midlife, if you will, at 40 years, to the extent you can share or what have you, you know, it's a mechanical device in a sense. Have we had, what kind of major problems and or kind of whether you would classify it as an accident, has there been anything like that at McGuire over its lifespan?
No, and even before we looked at going to extend the license, we monitor. And one of the things that we do during these maintenance and refueling outages is we go into locations, do lots of inspections, do non-destructive examinations on welds, on pipes, on components. We go in and look at oils, what our oils doing. You know, there's all kinds of technology we have that tells us what's going on with our equipment. And then we project out when does our equipment need maintenance or be replaced such that we don't find ourselves there. There's really nothing in the plant that we couldn't replace. We have large heat exchangers inside those concrete buildings that you have the picture of there that actually generate steam. We've replaced all 8 of them, and they're very large. And we did that about 15, 20 years ago. We replaced all of them. We can replace large components. The reactor vessel head, which actually goes, that we take off in order to do our refueling and put back on in order to operate, those can be replaced, and many facilities have replaced those. And we're looking at what point do we need to replace those here at McGuire. So the monitoring of the plant is such that we should always be in front of it, and we have redundancy. If something was to get past us, we have redundancy. So a single component like that that fails wouldn't. It may make the plant not be able to operate, but it wouldn't jeopardize the other plant.
Well, Lake Norman, obviously, even in the FERC applications, has part of its mission is to be a recreational resource for the region. And obviously you're a nuclear facility setting on a lake that people swim and play in. And, you know, people think about nuclear and they think about three-eyed bass and, you know, those kinds of things. To what degree, what's in the water coming in, coming out, and how much, and what does Duke do to monitor water quality?
And that's where I mentioned that we have the environmental facility. I have two environmental scientists that work in our chemistry department here that are constant. That's their role, is to monitor and to constantly be giving us feedback as far as what we're seeing. And then I have can reach out to the resources over at the environmental Applied Science Center and Environmental Center, and they are monitoring the lake. They're out on boats. They collect samples on the lake. They monitor those samples. I would say that as far as the things that most people think about the radiation, really the thing that we monitor is anything we're putting out. I'd say the thing that we have to watch the closest is the heat, is temperature of the water we discharge. We have strict limits on how hot the water is that we can put out into the lake. But I'll tell you, a lot of our local fishermen, they love us. One of the things they don't like about the pandemic is I've had to we allow them to come onto our property, and where our discharge is, they can fish there. Well, during the pandemic, because of what they could bring on site, we've had to stop that practice. And that's probably one of the main questions we get asked frequently is, hey, when are you going to open back up so we can fish? You know, and you watch them, they'll congregate out to where you're off our property out in boats. But a lot of them who don't have access to boats like to just drive over and fish on our property. So we monitor temperature very, very closely. It's probably the one that we have to watch the closest. The rest of them, all of them are public records. they come through, and it's a very large, we have both local, state, and federal requirements that we put out, and all the information is public, and it goes out on a regular basis. We're extremely regulated here, and we pride ourselves in our ability to monitor and meet the regulations and meet them in such a manner that we detect our own problems, as opposed to having a regulator tell us we have problems.
Yeah, we've been pretty fortunate in the Lake Norman area and on the lake itself. It's been a fantastic fishing resource. We even have professional tournaments, as you know, and you guys help sponsor.
Yeah, we do.
Kind of within the nuclear side, and you talk about refueling. Is this uranium based, or what's the fuel? And to the extent, can you talk about how you get it in, to the extent not violating confidential things, because I know there is a lot of restriction, but what do we do with the spent fuel? What is kind of fuels being used?
Okay, I'll go through that while I'm talking about it. If you go to the picture where I had the refueling, there's a picture on there. I can talk to you also about where we put the fuel. And so that concrete building that we have out there, that is the containment structure that holds the reactor when it's operating. And so every 18 months, and it's already here on site, the fuel comes in by truck. It's not a lot. It's about 70 what we call fuel assemblies. And there's actually in the slides, there's a picture about two or three more slides down of what a fuel assembly looks like. There you go. That's one fuel assembly. It's 12 feet long and about 1 foot square. And we're bringing about 70 of those. And that's all it takes to operate the plant for 18 months. They come in on trucks, and they come into the facility. We load those into a building. We have what we call our fuel after it's been irradiated and produced power. Once it's not at a point where we continue to operate it, we put it into a pool. So we actually bring in this new fuel in, and we put it in that same pool. And so we're all set up, ready to go.
And what kind of fuel is that?
That's uranium. It's actually a sort of a pellet that's there, and that's a ceramic. We actually take it and create ceramic pellets that's uranium based. Most of it's uranium-238, which most people have heard of, but the uranium-235 is what makes it be able to go through the fission process. Very low enrichment of that. It doesn't take a lot, less than 5%. Normally, enrichment's less than 1%, and we enriched up to about 5%. And then we put it in those pellets. Those pellets are in the rods, and then we have 264 rods in a fuel assembly. And we have we load about 72 of those. There's 193 actually in the core, so we move about a third of it out and put a third new into the reactor. So that fuel assembly will stay in the reactor about 4.5 years. It'll stay in there for 3 cycles before it comes out. So about 4.5 years, that'll produce power. Go back to the other picture, and so during the outage, we will have all that fuel staged. We'll move it. We'll flood up in the building. Everything will be underwater. We'll move out the fuel. We'll do all the maintenance that we do to the plant that doesn't require fuel in that building, and then we'll move the reactor back into the containment building, and we'll put that new fuel in with it. 1/3 of it came out, stays in that pool, and it basically cools. After about 10 years of cooling, it's cool enough where it doesn't need to stay in water anymore. And so we'll go through a process where we'll load 25 of those into canisters. And those canisters will be moved out. If you see that picture there with the concrete canisters, there's a metal cylinders in the center and then a concrete donut around it that provides some shielding, but there's no water anymore required. It's air cooled. And so we put those out. That's called a pad. And so those are moved out next to the plant. There's a pad. That picture there that you're seeing of the fuel, that is all that there, and the little bit that's remaining in our pool is all the fuel we've ever used in 40 years at McGuire. That is the extent of all the fuel that we have. And they're in the concrete overpacks. And that's where it'll sit until the plant is decommissioned.
Are those safe to walk around from a radiation perspective?
Yes, the requirements that we have, our employees on site, if you're at the site boundary and you were to stay there for a year, you would get the equivalent radiation of getting when you go to the dentist to get an x-ray or you get a chest. It's very low. You can actually walk. We actually daily have, they do inspections, go through there, make sure no debris has built up around the bases, and there's air-cooled vents that are on to make sure those vents are still clear. No birds have built nests or anything like that on them. Those clear, but we have operators and maintenance techs that walk through there, do inspections on rounds every day.
Yeah, I mean, Tom, with you being around, you've been around nuclear facilities for 30 years. We don't see you glow, so it must be.
No, I don't.
If we change a little bit, one of the topics mentioned was security. Can you talk about the security at the plant from both a physical perspective, because we know the environment we live in today, but even more so, can you talk to the need, requirement, or the focus on cybersecurity as well?
I really expected to mention cybersecurity when you said that. So yeah, physical security, everybody on site goes through background checks before they can get badged. Even a visitor, and some of the folks here may been here before, know that you have to go through a background check before you, so that's where it starts. Even these 1,000 people we're bringing in for this refueling outage, they all went through a background check before they're allowed to be badged on site. Once they are been cleared and go through a badging process, they can get on site. And so that's the first part of security. To actually get on site, you do have to have both a badge and we have hand geometry, where you basically have to match your badge to a physical feature about you that matches you up and gives you access to the facility. We have both hand geometry scanners, and we have optical scanners on site that will scan your eyes, verify you are who you say you are, and match you up to your badge to give you access to the site. Cameras everywhere. We have a Duke. All of our security force is in-house. We do have some contingent workers that come in to help us for projects and stuff like that. For the most part, our security force are also Duke employees. You'll see some of them, you don't see all of them when you're on site. And cameras everywhere, you can't get on it. So I tell everybody, I said, always assume you're on camera, because you're probably on wherever you go on site. So we have all the physical, you can see the fences, the cameras, the security officers, all the pat downs, the detectors you pass through to get into the plant to get access to the plant. And even inside the plant, there are certain areas of the plant that are secured, such that you have to have additional clearance to be able to get through. As far as cybersecurity, we actually have a small team that monitors for cybersecurity, both in our corporate office and here on site. We have barriers that you have to go through for the parts that we consider safety for the plant and for the reactors. They're separated, so you can't really. They're air separated. There's no physical connection between them and the outside world. They're physically separated. And then we have other features that allow our other systems to be separated quickly from the outside world. But those systems are separated. And then we go through all kinds of reviews to make sure anything digital we do use, that we understand how you could access those systems and bridge that gap from the outside world.
So I guess in both environments, that being the physical security and the cybersecurity, you go through testing of that, trying to breach it internally, and that sort of exercise as well.
We absolutely do. We have a team that's constantly looking at if there's any attacks that's on the cyber side, but on our physical security side, our regulator will come in every 3 years and actually do a drill to where they'll test our physical security on site, and our security officers have to respond, use their procedures in order to demonstrate that they can defend the site. Very hardened structures and very hardened site. So you have the physical side of the people defending the site, but also the way the site is designed makes it very, very challenging as well. In addition to the regulator doing that every 3 years, we do it annually here on site to keep our skills up, and we're also required to do internal drills on a regular basis as well. And so yes, all those features get tested on a regular basis to verify that they'll work properly.
Well, we were talking about this morning before we got started, knowing some of it without breaching specifics, but I always tease people about the security forces at McGuire. Is somewhere between a cross with a New York City SWAT team, Navy SEALs, and the National Guard. And as I tease, you couldn't attack a country, but no country would really want to attack you. You're pretty good defense.
Yeah, that's what I was saying, is that the defense is our specialty. We're not here to be an offense. We are definitely put our focus on defense at the site, and I think that we're in a really good position to be able to defend the site.
Well, I think, we're at the kind of close of our time. It has been an absolute pleasure to have you here. What McGuire is as a resource for our community and region is bar none. It's why the environment has developed, the community has developed. It is really attributable to Lake Norman, to Duke Energy, to McGuire. You're an asset and a credit to our community. Tom, any last comments or anything you'd like to leave us with?
Well, I usually at this point offer, we do offer tours and visitors and, real estate agents, local community leaders to see our facility. We want people to feel comfortable with McGuire being here. With the pandemic right now, we are not allowing that. But at some point, we all hope that we're out of this and we can open back up to allow some of that to occur. So I really want the local community to feel comfortable with what we're doing here. If they have any questions, reach out to us. Our Energy Explorium still has folks you can call out to if you have questions. It is not open right now to appointments, but we do hope to get it open soon when the pandemic clears, to allow our local, schools and community to be able to come to learn about how we generate power here. Energy Explorium doesn't just do nuclear. We also talk about all the forms of methods that we generate electricity for the community at Duke Energy. And so I'm very excited that the Chamber had asked me to come and do this, and I am definitely available for any type of functions that you want to invite us to, because I do want people to feel comfortable and know that we are operating this facility safely, and that we do understand our accountability to the community.
Well, again, Tom, thank you for being here. John Crutchfield, I know you've been on as well, a member of Duke and an active part of our community and part of the Chamber. John, we appreciate your service tremendously. So with that, I turn it back to Richard. Richard, the floor is yours.
Thank you, Jeff, and thank you, Tom. That was a great presentation and gave us and our members a good background and good current information on a very great resource. And as I said before, a very strong corporate partner with the Chamber and with our members. So thank you very much. Look for additional content on our website as we continue to put forth various programs like this one. And we thank you for joining us this morning. Have a great weekend.
Thank you.